All right, guys, for this problem, it says the graph of the function is shown below. Sketch a graph of the derivative of f. All right, so this is the original function. I want to know what the derivative would look like. Well, remember, the first thing you want to do if you've got a function is find the critical numbers. Well, the critical numbers of a function are where the derivative is equal to 0 or undefined, but graphically wise, it's where you have a relative extrema, like a max or a min. So if you notice, there's a max and there's a min. So that means that at those two values, my derivative is 0. So that means that if I'm gonna do my derivative, here's what I'll do. I'll do it in green. So my derivative function is in green. Since there's my max and there's my min of the function, the derivative at those two places is 0. So that means the derivative graph would have to be at 0 for those two values. All right, so now let's take a look at this left-hand side of my first interval. Notice that the graph is increasing. Well, when the graph is increasing, that means the derivative is positive. So that means I'm going to have a positive value for the derivative. All right, well, in between this interval, notice that the graph is decreasing. Well, when it's decreasing, that means the derivative is negative. So I'm going to have negative values. All right, and then finally, let's look at this graph, part of the interval of the graph. Notice that the function is increasing. So when the graph is increasing, the function is increasing. That means the derivative is positive. So this isn't an exact match for the derivative, but it's a good guesstimate or estimate of what the derivative would look like. It would basically be decreasing and then increasing, but I do know where the zeros of the derivative are, and I also know what it's doing between each interval.